If you wanted to calculate mortgage repayments over a number of years, 15, 20, 25, that could involve quite a few lines of Excel, where you take your initial value and you work out how much you would have to repay each month, how much interest gets added each month, how much you have to repay each month, how much interest gets added each month. So if that was over 20 years, for example, that would be 20 times 12. So it would be 240 lines of Excel to work out how much you pay each month, how much interest is added, how much you pay each month, how much interest is added. And then you would be able to figure out how much you have to pay each month. Luckily, Excel has a function to do all of that work for you. It's called PMT, for payment. So here in our example, which is called mortgage, we have the house value, the amount borrowed. We have a clever little one value divided by the other here to work out your loan to value, the interest rate, and the number of years to repay. So these four values are entered in yourself. What we would like to do then is for the monthly repayment to be calculated for us. Well, the start point is equals, like all functions, PMT, which stands for payment. Open brackets. What is the interest rate? Well, it's this one here. However, that's the interest rate per year, and we're looking at monthly payments. So we need to divide that by 12, comma, N per, the number of payments. Well, we have here the number of years, but we're again dealing in months, so we need to multiply that by 12 to get the number of payments. So we take the cell value, multiply by 12, comma. What's the amount that we're borrowing? PV standing for present value. Well, the present value is 350,000. That's how much we borrowed today. The next two parameters are optional and we don't need them. The future value is where do we want to get to? Well, we want to get to 0, but that's the default. And then the type just controls whether the interest is charged at the beginning or the end of the period. So the beginning or the end of the month. The default is the beginning, and really over a 25-year period, it will make a difference, but not a massive amount of difference. So this is our function, close brackets. So it takes our interest rate and divides it by 12 to turn that into a monthly interest rate. And then it multiplies our number of years for our loan by 12 to get how many months it will last. And then B2 is the value we are borrowing. When I press return, it then says it will cost me $1,752.18 each month. Now that I have this in place, I can experiment with the other values. What would happen if I borrowed a little less? Then the amount per month will go down. What if the interest rate was even lower? Then again, the amount per month would go down. If I'm paying less each month, perhaps I could start to look at paying this over a lesser period. So let's say 20 years. And the monthly amount goes up because I'm obviously having to cover the amount in a much shorter period of time. Perhaps I could try and pay this off in 15 years. And I'm looking at another $300 per month on top of my previous amount. So that's the PMT function. Very clever, just requiring those three numbers: interest rate, number of payments, and the actual value. Now we can make our little mortgage calculator a little cleverer by doing something with the LTV. Over on the right, you may have noticed a little table here. In this little table, we have a number of LTVs, the loan to values. If you have a higher loan to value, then your interest rate goes up because you're of a bigger risk to the mortgage company. The lower the LTV, the better interest rate you will get. So we need to make use of this little table in our interest rate cell here. Instead of entering the interest rate, we can experiment with the interest rate by looking at different amounts borrowed against the house value. So in here, I need to do a VLOOKUP. I need to look up the LTV percentage here. Now the actual value in that cell is not 50%, it's 0.5, whereas my table contains full integers. So what I need to do to my C2 is actually multiply it by 100 to turn it into full integer value, comma. I then need to take that new value, which will now be 50 at the moment, across to my little table here. So I highlight the table, comma. Having arrived at that table, I need the value that is currently stored in the second column. So I put a 2, comma, and then the range lookup needs to be true in this case. It cannot be false because I won't be able to find an exact match all the time. If the LTV, for example, is 54, 54 does not exist in this table and we would not get a match. So we need to go true and have an approximate match. And then I can close my brackets, return, and it says at an LTV of 50%, which is there, I will have to pay 2.8 interest. If I need to borrow more, my LTV goes up to 88, and we come into our table, and 88 falls into this bracket here, between 85 and 100. If I need to borrow the whole value of the house, LTV becomes 100, and 100 is 5%. And my monthly repayment really shoots up, in which case I would need to push back out to 25 years. So we can experiment just with a little set of formulas. One, to calculate the LTV, loan to value. One then looks up loan to value in our little table over here, provided by the mortgage company. And then the PMT uses the years, which we can experiment with, the interest rate, which is driven by the LTV, and the amount we're going to borrow to see what the monthly repayment is. So that's the PMT function for calculating monthly repayment on an amount borrowed over a particular period with a set interest rate, all of which we can adjust the variables for and get a different return on the payment due.